Unit 2, Lesson 5, Various Equations 2. The focus of this lesson will be on solving for the variable x when we have a radical or a square root involved. So let's look at some simple equations that I know you're used to seeing. If I provided you this equation and I asked you to solve, in order to isolate the x, you would take the square root of both sides. Now this tells me there's going to be two answers. So I'm going to have a plus or minus on the opposite side of the equal sign, and the square root of 4 is 2. That means both x equals 2 and x equals negative 2 would make this original equation that's in black true. Let's check. 2 squared, yes, in fact it's 4, and negative 2 squared is in fact 4. A common mistake I do see students make is when you plug into the calculator, a negative sign and you're going to raise it to an even power, if you don't put in parentheses, it'll be wrong. For instance, we all know negative 2 times negative 2 is a positive 4. We know that. But watch, if I take negative 2 and I square it, we do not get a positive 4. The reason for that is the calculator reads this as negative 1 times 2 squared. That's how the calculator reads it. So anytime we are checking our answers and we're plugging in a negative number in, make sure it goes in parentheses. So I'm going to show you in this very simple problem right now. If I take 2 and I square it, yes, I get 4. If I take negative 2 and I square it, yes, I get 4. Okay, let's look at the next one. This was my helpful hint that I'm going to have two answers. Next, let's take this simple equation. Now, how do we solve? Well, opposite of squaring was square root, and opposite of a square root is squaring. So whatever I do to the left, I must also do to the right. The square root and the square are going to simplify to 1, and I bring down the x, and 4 squared is 16. Now, we can check to make sure that works. The square root of 16, yes, equals 4. Let's take just a second here. You're writing everything down that I'm going over right now. Just a little bit of a review. We have talked at the Algebra 1-2 level, maybe 8th grade, depending on when you had Algebra 1-2, that whatever value you get inside of a square root, in order to get a real number, this value must be greater than or equal to 0. We'll learn later on this year what do we do when the value inside is not. But at this point, we're only talking about real number solutions. This must be greater than or equal to 0. All right, let's look at a few more things. We're going to look at this expression. There's no x involved, so it's an expression, and we're going to evaluate. What is the square root of 9? The square root of 9 is simply 3. What is if we evaluate a negative square root of 9? Well, the negative sign stays in front, and we still know that the square root of 9 is 3. Now, in this situation, just like I did with the negative sign, it pops in front with a plus or minus, and the square root of 9, again, is 3. Here, I'm going to draw an arrow to the square. This tells me I'm going to have two answers. I take the square root of both sides because opposite of squaring is square root. Whatever I do to the left, I must do to the right. These, a lot of times we think cancel out. They're going to simplify to 1, so I'm left with just x, and we know the square root of 9 is 3. Now, why did I do this problem? It looks great, but why is it wrong? Raise your hand if you know. What is it? Two answers. This tells me two answers. There's going to be a plus or a minus in front. I'm only going to have you write down this one equation right now, and we're going to go through it slowly. Bless you. Now, before I go any further, remember, after I get an answer, I got to plug it back here to make sure that it works. There's things that are called extraneous solutions. It means you do all the math right, but when you plug it back in, it doesn't make sense. For us at this level, we are only working with real answers. That means when I plug in a number back into here, I need to get a value that is 0 or greater, what we just spoke about. All right, let's get started. I want to start by getting this by itself. I want to isolate this portion. So I need to move the negative 3 to the opposite side. I'm going to do that by adding 3 to both the left and the right. These are additive inverses. They cancel out. And I bring down the square root of x minus 5. 0 plus 3 is 3. My goal now is to get x by itself. And so I'm going to do the outside and keep going all the way down to x is by itself. Opposite of a square root is a square. Whatever I do to the left, I must do to the right. I'm left with x minus 5 on the left-hand side, and 3 squared is 9. A common question I get is, Miss Bradley, am I supposed to put a plus or minus here? Like, how do I know when I'm supposed to do a plus or minus? Notice that here we have a square root, so I just have one answer. Here we have a square root, I have one answer. Here there's a plus or minus. That's why there existed two answers. It's when you're provided with x squared and you're solving for it that you know you're going to have the potential of those two answers. I do not have that. I do not have that. Okay, I'm going to add 5 to the other side, and I end up with x equals 14. Now, we can't, at this point in our math career, we can't just assume that's correct. We are welcome to do mental math, but if you prefer to use a calculator, you can do that as well. Remember, half of your test does not involve a calculator, and you don't get to decide when you get to use it and when you don't. I think the majority of you can just do simple mental math here. But if you're not comfortable, you would take a calculator and find the square root. 14 subtract 5, I use the arrow to go in back, minus 3. This has to equal 0 if this is the correct answer. It does equal 0. I'm going to put a little star there saying that I justified and it works. All right, we're looking at the second main example here. So just like in the previous example, I said we want to get this radical by itself first. We're going to do the same thing here. So make a little underline here. We want to get this portion by itself. In order to get the square root of x plus 2 by itself, I have to move the subtracting x. Opposite of subtracting x is adding x. So I have the square root of x plus 2 is equal to, and how I write these doesn't matter. What I mean by that is I could write negative 4 plus x, or I could write x minus 4. Either way, I have a positive x and a negative 4. Now, to isolate the x, I need to start by removing that square. The opposite of a square root is squaring it. So I'm going to both square both the left and the right-hand sides. And this is where it gets a little bit complicated. On the left-hand side, it's pretty easy. The square root and the square, they're going to simplify to 1. I know many of you think of that as canceling out, and I get to bring down x plus 2. Now over here, this says write this quantity twice. So let's write down x minus 4 times x minus 4. If you need a little review, FOIL means front, outside, inside, last. So I'm going to do that right now. I'm multiplying the fronts to get x squared. I'm multiplying the outsides to get a negative 4x. I'm multiplying the inside to get a negative 4x, and I'm multiplying the last terms to get a positive 16. I want to move everything to the same side. Well, there's 4 terms over here, and the leading coefficient is positive. So it's going to be to my advantage to move everything to the right-hand side for this problem. So I'm going to subtract 2. They're additive inverses, so they cancel out. I'm going to subtract x. Additive inverses, and now I have nothing left on the left-hand side. On the right-hand side, I'm going to start by combining like terms. X squared, okay, I've taken care of that term. I have 3 terms that have a singular x. Negative 4 and negative 4 is negative 8, and negative 8 and negative 1 is negative 9. 16 minus 2 is 14. This goes back to what you learned freshman year, and we started the beginning of this unit with, and that was working on factoring. So we have a trinomial. How can we do this? Well, we can try factoring. Doesn't mean it's going to work, but it may work. If factoring doesn't work, we can always use the quadratic formula or completing the square. Let's check if factoring works. 1 times 14 is 14. Are there 2 numbers that multiply to give you a positive 14 and combine to give you a negative 9? There are. Negative 7 and negative 2. Both negatives, so they multiply to give us a positive and combine to give us a negative. Now I'm going to do the AC plus B method because that's the preferred method by the majority, but I want to remind you, you can use the McFarland method, which is kind of brute force method. You can use Castro's method. You can use bottoms up, whatever works that you can consistently factor trinomials correctly. So minus 7x minus 2x, and now factoring by grouping. I can factor out an x, I'm left with x minus 7. I'm going to take that x minus 7, write it over here. What times x is a negative 2x, a negative 2. Negative 2 times negative 7 is a positive 14. So this is great. Both the front and the back half contain the x minus 7. Now I'm going to cover up that x minus 7, and in front we can see there's an x, cover up the x minus 7, and in front we can see there's a negative 2. Those are my 2 factors. I'm going to set each one equal to 0 and solve, and then I have to check for extraneous solutions. So I believe one answer is 7, and I believe the other answer is 2. Now, here's what I need to tell you. In your pre-calculus AP exam and in your calculus AP exam, you have to show every single step. Did you hear that? Every single step. So that's where I completely understand when you're here, I would just want to write x equals 7 and x equals 2. They will dock you and not give you your points on the test. Okay, so we are preparing for that final exam. Please make sure you're being respectful. All earbuds are out. I have these 2. Can I just assume they're right? I cannot just assume they're right. So I have 7 and 2. Let's grab a calculator or use mental math. It is up to you. It is up to you in this situation. I'm going to check 7 first. I'm going to take the square root of 7 plus 2. I'm checking 7. I move outside of the radical. Minus, I'm going to substitute in that 7. And what do I want for an answer? I want negative 4. If I don't get negative 4, it's not right. I did get negative 4. I'm going to come down and put a star next to x equals 7. Let's do the next one. I'm now going to check 2. Could you use mental math here? Absolutely. 2 plus 2, move outside of the radical, minus a 2. I want an answer of negative 4. Did it work? It did not work. What does that mean? Please cross this out. We're going to put a capital ES. This means this is an extraneous solution. It's an example of an answer. You did all the math right, but when you plugged it back in, it did not work. This is our third main example, and just like examples 1 and 2, we want to start by getting the radical by itself. So how do I do that? Well, I need to move these to the opposite side. So opposite of a positive 4 is a negative 4, and opposite of a positive 2x, of a negative 2x is a positive 2x. These are additive inverses. Same term, different signs. So on the left-hand side, I'm left with the square root of 2x plus 10. Now on the right-hand side, I have a couple things here. I have a 14 minus 4. I can combine those to give me 10, and I have a positive 2x. Now there's a couple different ways we could go about doing this. So I did this problem in 2 ways. I got the same answer here. I think I'm going to do it the longer way, just not to complicate you as we initially start to learn this. So my thought right away is, let's factor out a 2. Let's make this easier and factor out a 2. And if you choose to do that, feel free to do that. Remember, my goal is to get rid of this radical. It's kind of like when you have an equation and there's no fractions, it seems easier to work with. Well, when you have an equation and you're trying to solve for a variable and there's no radical, it's easier. So how do I get rid of a square root? We're going to square it. So let's both square the left-hand side and the right-hand side. Okay, the square root and the square are going to simplify to 1. We bring down 2x plus 10. Now I need to write this quantity twice. 2x plus 10 times 2x plus 10. And that's a really common mistake. Most students, when they get this wrong, they write 4x squared plus 100, and they forget to write it twice. When you write it twice and FOIL it, you're going to get those middle terms. So at this time, I'm going to FOIL. I'm going to multiply the fronts. 2 times 2 is 4, and there's an x squared. I'm going to multiply the outside to get a positive 20x, and the inside also gives me a positive 20x. I'm going to multiply the last. 10 times 10 is 100. Now on the right-hand side, just like example number 2, we have a leading coefficient that's positive, and the majority of the terms are here. So I'm going to move these 2 terms from the left over to the right. That's not a y, that's just an ugly x. Ugly x. All right, here we go. I have a 4x squared. Okay, I've taken care of that. Now I have 3 terms here. 20 and 20 is 40, so this is 40x, but then we have to subtract 2 to get a positive 38x. And 100 minus 10 is a positive 90. I'm going to press pause. So we have a trinomial. Let's review what we can do. We could factor it, we could use the quadratic formula, or we could complete the square. Now most students don't choose to complete the square. Most students are either going to see, can I factor it, and if I can factor it, that will be their route. Some students are set on the quadratic formula because they know that always works. You choose what works for you. So I'm going to go through this right now, and I'm going to work on factoring. But you know what? I see a 4, a 38, and a 90. I know they are all even. And I'm asking myself, what's the largest number I could factor out of 4, 38, and 90? Well, I know that 1, 2, and 4 all go into 4. So I'm going to try a 4. Let's try 38 divided by 4. 38 divided by, oh, that doesn't work. But I know they all divide by 2 because they're even. So let's try factoring out a 2. If we factor out a 2, I think that it will be easier for us to factor the trinomial. 4 divided by 2 is 2, bring down the x squared. 38 divided by 2 is 19, bring down the x. And 40 divided by 2, 90 divided by 2 is 45. If you see me make a small arithmetic mistake, just holler. So I divide by this 2, and 0 divided by 2 is 0. I'm left with this trinomial. This is what I have to factor. The 2 that I divided was this 2 that's out front by itself. So I'm ready. Here we go. Let's see. Is this factorable? 2 times 45 is 90. I'm going to press pause here, and working with your partners, I'm going to see in 30 seconds, you can use the calculator, are you able to come up with two numbers that multiply to give you positive 90 and combine to give you 19? All right, so what are we going to do? Well, I'm going to cover this up so we don't get confused with the other problem, and I'm going to do it right now with you. I have not taken time to think through this. So if you're wondering, like, how do you come up with these numbers? Well, let's think through the process. 90 divided by 1 is 90. So 1 and 90, they don't somehow give you 19. Let's divide it by 2. Oops, excuse me. Take 90 and divide it by 2. Well, 2 and 45, they don't give us 19. Divide it by 3. 3 and 30 don't give us 19. Divide it by 4. Okay, I don't want it to have a decimal. Let's divide by 5. 90 divided by 5. Okay, 5 and 18 is closer to 19, but not the correct number. Let's divide it by 6. Okay, I'm getting closer. I'm at 21. Divided by 7, it does not work. Divided by 8, it does not work. Divided by 9, okay, here we go. 9 and 10 give us 19. So, positive 9, positive 10. So I'm going to write this as, and let me move this down so you can see this. I'll move it up for people in the back. Again, you use whatever method works for you that consistently, correctly factors, allowing us to solve accurately. So I'm going to drop in a positive 10x and a positive 9x. Make sure to include the x behind it. It doesn't matter if you do a 9 first or a 10. It's all up to you. Now, I'm going to do factoring by grouping to continue. I can factor out a 2x, and I'm left with x plus 5. 2x squared plus 10x. I rewrite the x plus 5. Is there a number I can take times x and get a positive 9x? There is. And 9 times 5 is 45. They both contain an x plus 5. In front of the first is a 2x, and in front of the second is a positive 9. Why do we learn the factoring? Because factoring is a tool to now solve. I'm going to take each one of these factors, I'm going to set them equal to 0, and I'm going to solve it. Please make sure you are showing all of your steps. Now, just because I got a negative 5 and a negative 9 halves, that does not mean that both of those answers work. Turn to your partner in 5 seconds. What do you have to do to ensure that they do work? Turn to your partner. Go. What do? You got to plug them in. So let's grab our calculator in this situation. Let's check this out. You ready? Let's do this a little bit slower together, because sometimes it's like, what buttons do I push? So I'm going to hit the blue button and go straight down about 5 keys until I find the square root. And I'm going to start by trying a negative 5. So negative 5 goes in parentheses plus 10. I move outside of the radical by using the arrow to move to the right. Subtract 2 times negative 5 plus 4. Now, how do I know if negative 5 is a correct answer? When I press enter, it must equal 14. It does. I'm going to come down in here and put a star. It means I have checked it, and it works. I'm going to do the same thing right now for negative 9 halves. Square root, you should be doing the same right now at your seat with the calculator. I'm checking my work here. 2 times negative 9 halves plus 10. I move outside the radical. Negative 2 times negative 9 halves plus 4 must equal 14, and it does. So in this situation, I do have 2 correct solutions for this radical equation. I believe this is our 4th example. Is that correct? All right. Our goal again is to get this by itself. And so I'm going to move the terms that are either being added or subtracted, not multiplied. As a reminder, PEMDAS, please excuse my dear Aunt Sally. When we're solving for a variable, we're starting at the bottom and we're working our way up. Okay, you ready? Here we go. I'm going to add 2 to the opposite side. I'm going to subtract 8x to the opposite side. Positive 8x, negative 8x, added to inverses, they cancel. And now over here, I have a positive 4x and a negative 8x. So I'm going to write down a negative 4x, and I have a positive 7 and a positive 2, which is a positive 9. As a reminder from the previous example, you could write down negative 4x plus 9 or 9 minus 4x. They're the same answer. What matters is you have the correct term with the correct sign. Can I have a thumbs up or a thumbs down right now if you've understood up to this point? Thumbs up or thumbs down? Okay, here is where it gets a little more difficult. I generally would say, let's divide by 3. Now, don't do that. But I generally would say, let's divide by 3. Let me see if I have a pencil here that I could use that I can also erase. And here's why in this problem I would not do that. Okay, dividing by 3, wonderful. That's normally what we do. This has to be shared with the left and right, so 9 divided by 3, wonderful. It divides to 3. But does 4 divided by 3 divide nicely? And for that reason, I think it complicates it. So instead, we're going to move forward without dividing by 3. We can still get the correct answer. Okay, you ready? I need to figure out what do I do here. So turn to somebody next to you. What do you think we can do to still get rid of that square root? Go ahead. What do you think we can do? Yeah, we can square it. Please put parentheses around the left and right. I need to remind you really quickly of a rule. So I'm going to come off to the side here. If I have a times b and I square it, this is just rules of exponents. I want to remind you that we distribute it to both, so it becomes a squared times b squared. And that's exactly what we're going to do here. This square is going to apply to the 3 and to the square root. So 3 squared, I know, is 9. And the square root of 4x plus 1 squared, well, you think of it as canceling out. Realistically, it simplifies to an exponent of 1, and we bring down 4x plus 1. Now, on the right-hand side, a really common mistake is students want to say, don't I just distribute like this? So it's 81 plus 16x squared. No, no. Take this quantity, and we're going to write it twice. Now, if you're a fast processor, feel free to work ahead right now. Just check as you go along to make sure you're getting the same answer that I am. So I'm going to start right away by doing FOIL, front, outside, inside, last. I'm going to multiply the fronts, multiply the outsides, the insides, and the lasts. Again, if you get any answer other than myself, just please let me know. Over here is 36x plus 9. All I've done is I've distributed. Foiling is distributing. Now I need to ask myself, do I move things to the right or do I move things to the left? It's always to our advantage to have the leading coefficient positive. And since the leading coefficient is positive on the right, and the majority of terms are on the right, I'm going to move everything over to the right-hand side. Minus 36x, minus 36x, minus 9, minus 9. And when I rewrite this, I'm going to put it in standard form. Some value x squared, some value x, and the constant. So there's only one term that has an x squared, that is 16x squared. There are three terms that have an x. So I'm going to take negative 36 times 3 quickly, and I end up with negative 108x. And if I subtract 9 from 81, I have a positive 72. I'm going to let you get caught. Great. So, yes, we're going to try to solve this. And we can solve it by factoring, maybe, always quadratic formula, and completing the square. But the first thing I want to do is I want to ask myself, okay, can I factor something out just like I did in example 3? So I choose the smallest term, which is 16, and I'm going to write down the numbers that divide into 16. 1, 2, 4, 8, and 16. And then I'm going to use my calculator. And so what I'm doing right now is I'm testing. I'm going to start with the largest number. 108 divided by 16. Oh, it's not nice. Cross it out. 108 divided by 8. Oh, not nice. Let's try 4. 108 divided by 4. That works. I got a nice whole number. 72 divided by 4. Oh, I got a nice whole number. So I'm going to factor out a 4 right now. Factor it out a 4. 16 divided by 4. 108 divided by 4. 108 divided by 4. I bring down the negative sign, is a 27, 27x. 72 divided by 4 is an 18. All right, and just like we did in example number 3, let's get rid of this term out front that has no x. So let's divide both sides by 4. 0 divided by 4 is 0. Oh, that's pretty simple. I'm going to take that paper I previously used, give me 1 second, and move this up so we can see. Again, and if you're feeling pretty confident, I would love for you to work ahead here. I'm going to take 0 and set it equal to 4x squared minus 27x plus 18. Go ahead and solve. Here we go. 4 times 18. Well, 4 times 18 is 72. I want to know what two numbers multiply to give us 72 and combine to give us a negative 27. Remember, if we can't factor, it doesn't mean we can't do it, then we're going to go to the quadratic formula. You can always go directly to the quadratic formula. So here's my thought process. 1 and 72 is not going to be 27. I know they both have to be negative to get a positive and then combine to give you a negative. 72 divided by 2, 2 and 36, no. 72 divided by 3, 3 and 24 do work. 3 and 24 work. You use whatever factoring method consistently works for you with trinomials. I'm going to drop in the 3 and the negative 24. The order I drop them in does not matter. Make sure to put an x behind each. And now I'm going to do factoring by grouping. I can factor out a 4 and an x, and I'm left with 4 divided by 4, x is 1x. So 4x times x is 4x squared, and 4x times negative 6 is negative 24x. I rewrite the x minus 6. I'm asking myself, what times x is a negative 3x? That's a negative 3. And negative 3 times negative 6 is 18. They both contain the quantity x minus 6. I cover up the first group of x minus 6, I'm left with 4x. I cover up the second group of x minus 6, I'm left with negative 3. Another mistake students often make is they do all of this wonderful work that shows they understand it, and they stop here. Our goal is to solve. So I'm going to take each one of these quantities, I'm going to set it equal to 0, and I must show my work. Plus 6, plus 6, plus 3. Does it mean that both of these are the answers? It may, but I don't know. So I need to come back to the original problem. Let's use our calculator since this is a little more complicated. And let's start by testing 6. So grab your calculator. In fact, you know what? I'm going to have you do right now. So in front of me, students are testing 6 and 3/4. I'm going to test 6. Okay, this is my right-hand side when I'm testing 6. This is my left-hand side. So I just tested 6. I just tested 6. And if you're wondering, well, how do we test this? I plugged 6 into the left-hand side. This is the quantity I got. I plugged 6 into the right-hand side. These two sides have to equal each other if it works. 6 did not work. I'm going to do the same thing with 3/4 now. I end up with 10 on the left-hand side when I plugged in 3/4. And I ended up with 10 on the right-hand side. The left-hand side equals the right-hand side. This is the correct answer. I already know this is going to be ugly. This is going to be ugly. Here we go. I'm going to take example 5, and I'm going to square both the left and the right-hand side. And I'm going to slow this down so that nobody feels overwhelmed. Now, the left-hand side is easy. The left-hand side, I'm left with 3x minus 2. Not bad. I'm going to write this out twice. It's the foiling part that I believe is going to confuse students. So I'm going to divert from this problem for just a second, and I'm going to ask you a question. If I gave you this, square root of 9 times the square root of 9, square root of 9 times the square root of 9, wouldn't you end up with the square root of 81? Because 9 times 9 is 81. And what's the square root of 81? 9. Let's try another one. Square root of, let's go 3. Square root of 3 times the square root of 3 is the square root of 9, which just gives you 3. So tell me this. If I said square root of z times the square root of z, what would you be left with? Simply z. Do you see how when you take the square root of the same quantity, you're just left with that quantity inside? So keep that in mind. Here we go. You ready? Here we go. The square root of x times the square root of x, when I FOIL the front by distributing, is simply x. Give me 1 second. All right, so we multiply the fronts. The square root of x times the square root of x is x. And if you're like, Miss Bradley, I can write that down, but it still doesn't make sense to me. Let me come off to the side and show you. Square root of x times the square root of x. Well, that's the square root of x times x is x squared. And what happens to the square root and the square? They cancel and you're left with just x. That's how you get it mathematically. Let's do the outside. 2 times the square root of x is simply positive 2 square roots of x. The inside is simply 2 square roots of x. And the last or final piece is positive 4. Okay, I want you to combine like terms right now. Combine like terms. My goal is to get this portion together on one side. Like I want to keep the radicals on one side together. So I'm going to move the x to the other side. Positive x and negative x cancel out, and I'm going to move the 4 to the other side. Positive 4 and negative 4 cancel out. So on the right side, I have two groups. They're exactly the same. I have a positive 2x and I have a positive 2 square roots of x and a positive 2 square roots of x. When I combine these two terms, I'm left with 4 square roots of x. I didn't multiply them, I combined them by adding. On the left-hand side, 3x minus x is 2x, and negative 2 and negative 4 is a negative 6. Now generally, just like we did in the previous example, I'd say, let's divide by 4. Why do you think it's not to our advantage to divide by 4? Anybody? Yeah, if I divide by 4, am I going to get a nice fraction here? I'm not. That's the only reason why. So if I'm not going to divide by 4, I know JD said it last time, what do you think we could do next? Yeah, let's square both sides. On the right-hand side, this needs to be applied to both the 4 and to the square root. So it's going to be 4 squared and the square root of x squared. On the left-hand side, I have 2x minus 6 times 2x minus 6. If you're feeling confident, I want you to continue to move ahead. If you're feeling confident, continue to move ahead. All right, here we go. 4 squared is 16, and I have the square root of x squared. Well, the square root and the square cancel out, and I'm simply left with x. On the left-hand side, I'm going to FOIL all of this. So multiplying the fronts to get 4x squared, multiplying the outsides, a negative 12x, inside negative 12x, and negative 6 times negative 6 is a positive 36. I'm going to bring that over here where I have a little more space. 4x squared minus 24x plus 36 equals 16x. Now, do you think I want to move the 16 to the left, or do I want to move the items on the left to the right? Well, there's two things. Always look at the leading coefficient. If it's positive, we really want to move things that way. So let's move the 16 over to the left-hand side. I have nothing left on the right-hand side now, and when I combine like terms, I have 4x squared, making sure I'm doing my math here right, minus 40x plus 36 equals 0. It's just like the last two problems. It's always going to be to our advantage if we can factor something out first. So I look at these three numbers, and I go, what's the smallest one? It's 4. What numbers divide into 4? 1, 2, and 4. So I grab my calculator, and let's try the largest number first. So 40 divided by 4, hey, it's a nice number. Let's try 36. 36 divided by 4, oh, it's a nice number. There's no decimal, so let's factor out a 4. Camila, do you know what you would do next? Say it a little bit louder. What do you think you do? Okay, that's going to be what we're going to do at the next step after that. Does anybody know what the next step is going to be before we do that? Divide by 4. And then we're going to come back to what Camila said. After that, exactly. So the 4 that's being multiplied and divided, these are inverse operations. They simplify to a 1, and I'm left with 1x squared minus 10x plus 4, and 0 divided by 4 is 0. Now we go back to what Camila said. We're going to try to solve using factoring. What if factoring doesn't work? What do we do? Quadratic formula. And you can always use a quadratic formula. What multiplies to give us 10 combines to give us negative, what multiplies to give us 9 combines to give us negative 10, negative 9, and negative 1. So 1x squared minus 9x minus 1x. And when you factor these down, I'm just going to write it down quickly. It's going to look like this. If I do all that work and I stop now, I have not solved. I have to take each one of these factors, I set it equal to 0, and I have to show my work to get x equals 9, and I have to show my work to get x equals 1. Does that mean this problem is done? No. Okay, what do I still have to do, Daniel? Yep, let's grab our calculator. Let's go up to this original problem. Luckily, it's not very long. Let's try 9. You guys try 1, and I will try 9. Go ahead, please. You try 1, and I'll try 9. My left side equals 5. my right side equals 5. So I know 9 works because the left side and the right side equal one another. So I know 9 works. Okay, you are trying 1. You are trying 1. Does 1 work? Yes or no? Anybody? Nobody's going to answer me. Okay, gotcha.
He said no.
He said no? Okay, perfect. No, okay. So we're going to cross it out and write ES. It's an extraneous solution. It means I did all the math right. You still have to show your work, but this is not a solution we can consider for this problem. This is our 6th and final example. Our 6th and final example. So what I'm going to do is I'm going to take this value. It's negative. I'm going to move it to the opposite side. And then I'm going to rewrite this. So on the left, I'm left with the square root of the quantity 3x minus 2. And on the right, I have 1 plus the square root of x plus 3. I really want to remove the radicals. If they're removed, it's going to be so much easier. What do you think we could do? Square it. Let's square the left and let's square the right. Let's square the left and the right. Well, on the left-hand side, pretty simple. I'm left with simply 3x minus 2. But on the right-hand side, I've got to write this down twice. Okay, I just want to take a quick moment here to remind us. If we take any value like the square root of 5x, the square root of 5x times the square root of 5x is simply 5x. Or if I take the square root of x plus 1 times the square root of x plus 1, I'm left with simply x plus 1. So just keep that in mind. Okay, here we go. You ready? I'm going to FOIL at this time. I'm going to FOIL, multiplying the fronts to get 1. Again, I just multiplied the fronts to get 1. I'm going to multiply the outsides to get a positive 1, square root of x plus 3. The inside is a positive 1, square root of x plus 3. The outside, it goes back to this rule. The square root of x plus 3 times the square root of x plus 3 is simply x plus 3. David, what do you think should be my goal in the next step? Yeah, to get the ones that don't have a radical on the right, to the other side. So I'm going to go, okay, I know that 1 plus 3 is 4. I know 1 plus 3 is 4. An opposite of positive 4 is a negative 4. An opposite of a positive x is a negative x. So on the right-hand side, I have 2 groups. Here's one group, and here's next. I have 2 groups of the square root of x plus 3. And on the left-hand side, when I combine like terms, 3x minus x is 2x, and negative 2 and negative 4 is negative 6. Now, this is the first time where it would work that you could divide. Why would it work to divide by this 2 now? It hasn't worked up to this point, but why would it work now? Turn to somebody next to you. Why now could you if you wanted to? Because when you divide and you share it with both the left and the right, you get nice integer answers. So 2x divided by 2 and 6 divided by 2, those are nice integer answers, okay? So I'm going to come over here where you can see this. 2 divided by 2 is 1x, 6 divided by 2 is 3, and this is what I have now. Josue, what would you do next? Our goal is to solve for x, and I want to get rid of that radical. What would you do next, Josue? Yeah. What number of the exponent? 2. So let's do that to both sides. Right-hand side makes it nice. I'm left with x plus 3. Now, here's where a lot of students make a mistake. Yvette, could you tell me what to write here? Yep. That's right. You're going to write it down twice. And I'm going to quickly FOIL right now. I get 1x squared minus 3x minus 3x plus 9 equals x plus 3. And just for the purpose of time right now, I'm going to speed up. You're like, you can't go any faster. I can. I'm going to move the x's to the other side, the 3's to the other side. I have nothing left on the right-hand side. On the left-hand side, when I combine like terms, negative 3 and negative 3 is negative 6. I have negative 7x plus 6. As fast as you can in the next minute, I want to see, can you factor and solve this? Go ahead. Did anybody in here, and I know that I work faster, but did anybody get an answer of 6 and 1? Hands raised. Anybody get 6 and 1? Okay, we have to test them now. Let's test them. Square root, I'll try 6. You guys try 1, please. Go ahead. You try 1. Pick up a calculator and go. I'll try 6. You try 1. So I plugged in 6, put it in parentheses, and I want it to equal 1. It equals 1. That tells me that I know 6 is an answer. I'm going to do the exact same thing and see if I can beat some of you. You definitely could have used mental math if that's what you prefer. I plugged in 1. Did you guys also get a -1 as an answer? Does -1 the same as +1? No. Cross it out and write an ES.